Hello friends, welcome to this video. Now from this video onwards we are starting a new series, that is miscellaneous topics series, where we are going to cover pressure temperature rating. Okay, this is the first topic in this miscellaneous topic series. In other videos we have already covered the introductory part, then design basis, process interface, pipe rack, column piping, pump piping, compressor piping, overall plot plan, unit plot plan, valve operation accessibility. I mentioned this duration also. You can easily watch anytime all these videos. I've given all the links in the description also, and many more video in the layout section are on the way. Soon you'll get all these video uploaded in this channel. So let us start with this topic. Here in this video, what we are going to cover? We are going to cover the pressure temperature rating, all the basic definitions, then pressure temperature rating understanding with an example. We'll take an example of this material A105, and we'll try to relate all the things of which are related to piping pressure temperature rating. Okay, then we'll try to cover we'll try to relate all these things with the flanges, which is a very important thing. So let us start with the definitions. So if you see what is pressure temperature rating, okay, pressure temperature rating is a maximum allowable non-shock gauge pressure at a specific temperature for a given material. Okay, I know this is a complicated definition, very short but complicated definition, but try to understand what we are going to cover. One is pressure, then temperature, and another is a material. Okay, so let us try to understand. Let us do some detailing of this definition. Okay, before going ahead, let us know this flange. This is known as flange pressure temperature rating. That is flange rating, PT rating, flange pressure rating for a flange or flange class. Okay, so these are all the names which we commonly use. But let us first try to understand what is pressure temperature rating. Okay, this is the agenda of this slide at least. So before looking into the definitions, first try to understand based on the ability of the material. Okay, whatever we are going to use, carbon steel, alloy steel, stainless steel, based on its ability to handle the stresses at a given temperature. Okay, now we have covered three things: material, temperature, and pressure. Okay, that is just ability of a material. We are talking about ability of a material to handle stresses at a given temperature. Okay, now we have a standard code with us, ACME B31.3. This is our basic code which we use for process piping. Has developed a maximum allowable stress value of a material, okay, at a specific temperature, and listed down all the values in a table given in the code. Okay, so we have ASME 31.3, where for all materials based on their ability to handle the pressure at a given temperature, everything is already mentioned, allowable stresses are mentioned. Okay, so now let us elaborate this thing. This is ability of a material. Okay, now let us relate it with temperature rating and pressure rating. Now piping materials such as carbon steel, stainless steel, alloy steel have different mechanical and chemical property. Okay, this is just a basic statement. This is applicable to all the materials which we are going to use in piping systems. Carbon steel, stainless steel, alloy steel, any material which we are going to use, they have different mechanical and chemical properties. Okay, now the same material can handle different amount of stress. Suppose we are using stainless steel, this can handle different amount of stresses at a different temperature. Okay, same material at different temperature, it can handle different pressure, different stress. Okay, now based on the ability of a material to handle the stresses at a given temperature, ASME has developed a maximum allowable stress value of a material at a specific temperature. Okay, which we have already discussed here. Same thing it is here. 31.3 shows ability of a material at a particular temperature. It establishes the basis to calculate the adequate wall thickness of a pipe, flanges, flange fittings, so that they can withstand the stresses due to pressure and other loads. Okay, so what we are doing, we are standardizing the temperatures for a particular material based on its ability to withstand the stresses at a particular temperature. Okay, now how pressure rating is related? It is more or less similar. Okay, the pressure rating is a safe working or maximum operating pressure with respect to working temperature. Okay, Now again we are talking about the property of a material which we are going to use in a piping, which we are going to use for piping systems. Maximum operating pressure with respect to working temperature, that is again we are saying ability of a material. Okay, it depends on the material stress strain characteristics, okay, which we have already discussed. We are going to check the ability of the material. Every material has its own stress strain characteristics. It is available in different codes and standards also, okay, but we are going to use 31.3. So now what we have done, we are trying to understand what is pressure temperature rating. Now what we have understood, there we are going to use different materials in different piping systems. Every material has its own ability to withstand the stresses which will be generated at particular temperature. Okay, now in next slides we will try to understand how this is increasing or decreasing with increase in temperature, how ability of material is changing, okay, when we change the temperature or pressure. So pressure rating is nothing but ability of a material. We need to understand every material has its own properties and it will change based on temperature. If we fix the temperature, then based on ability, based on pressure, it will react differently. Okay, so we need to 31.3 shows maximum allowable stress value for a particular temperature also. So this is very useful to identify so many things when we design piping systems. For example, we have to the basic thing which we need is adequate wall thickness of the pipe. How we calculate the wall thickness in pipe, we'll discuss in next videos. Here we are establishing pressure temperature rating is the basis to establish all these things. Okay, this is the uses where we are going to use, but first in this video we are trying to understand what it is all about. Okay, so next slide, let us discuss in detail. So if you see pressure temperature rating, let us understand with an example of material A105. Okay, every material has a different property, but we are taking example of A105. If you see, this is a chart. These are the temperature ranges. These are the pressure. This is the class. Okay, so pressure temperature rating table of ASME codes provide a limit of maximum working pressure at which a flange can be subject for longer duration at a specific temperature. Okay, in last slide we discussed the ability of a material, and that material is here in this slide A105. This ability of a material we are going to check with respect to pressure and temperature. For intermediate temperatures, linear interpolation can be done. Okay, if you see, if we are talking about between 50 to 100, then suppose we are talking about 75, then linear interpolation we can do to get these values for all the pipe classes. Okay, so now if you see, we are having pressure, we are taking example of this material, we have listed temperatures and the class. If you see, if we talk about this thing, okay, with increase in temperature the ability is decreasing. With increase in class at same temperature the ability is increasing. Okay, this is the basic thing which we need to keep in mind. We are talking about ability of a material, nothing else. Pressure temperature is nothing else but ability of a material at given pressure or temperature. Now what is happening, with an increase in temperature, pressure withstanding capability of same material decreases. Okay, as temperature is increasing, this is decreasing. This is what we are saying in the first sentence. So all these points we have to remember. Okay, with an increase in pressure class rating, pressure capability increases. As we are increasing the class, the pressure capability is increasing. That means the material can withstand higher pressures. With a change in flange material, pressure temperature table and pressure withstanding capability changes at the same pressure class. Okay, so if you see, if you change the material in the same pressure class, this will be different. Okay, so that is what it is all about, pressure rating temperature, ability of a material at particular temperature and pressure, that we need to check. Okay, so all these tables we can get in all the codes. So this is the basic, these are the basic things which we need to keep in mind. Increase in temperature, increase in pressure, how things are changing. This is mentioned here with an example. Now let us see the same pressure temperature rating concept with respect to flanges. This is nothing, it is all about flanges only, but let us try to relate more things about it. Okay, 16.5 is a standard of pipe flanges, as you all know. Flange fittings that covers flanges sizes between half inch to 24 inch, and 16.45 or 7 is more than 24 inch and up to 60 inch. In this standard, flanges are classified based on their pressure rating, which is also known as flange class. Okay, as we have discussed in previous slide, we can call it flange class or pressure rating. Okay, steel flanges. Now, according to 16.5, we are having these 7 classes: 50, 350, 300, 400, 600, 900, 1500, 2500. These are the basic classes which have been identified in this standard. According to this standard, pressure rating is a dimensionless number. Okay, this we have to keep in mind. We don't have any unit for any class. Anyhow, now let us look at one of the chart which we have prepared for different classes. If you see, these are the pipe sizes. These are the outer diameter of the flange. Okay, and this is the minimum thickness of the flange. We are trying to understand how things are changing with respect to size, rating and temperature, pressure. Based on that, we have come up to this chart. Let us understand how things are changing. If you see, the OD of the flange is increasing, thickness of the flange is increasing. Okay, we are talking about class 150. Same is the case for all these classes. As the increase, there is increase in OD, there is increase in thickness. Okay, so higher the flange rating, higher is the pressure it can withstand at a temperature. If we are working at a particular temperature, then higher the class, more pressure it can withstand. Thickness is increasing, size is increasing, so it can withstand more pressure. Flanges with higher rating have more thickness. As if you see, for 2-inch size, here the thickness is 17.5. As the rating is increasing, thickness is also increasing. Okay, so as the thickness is increasing, more weight and are stronger as compared to flanges with lower ratings. Okay, as the thickness is increasing, weights are also increasing. If you see here, for same 10-inch size, we have taken a 150 rating pound flange. Its weight is 24.5 kg. As the rating is increasing, weight is also increasing. Now it is, for same size, the weight is 44.5. Here it is more than 85 for 600 pound. For 1500 it is crossing 200 kg. So with the increase in rating, the weight is also increasing. That is what we are trying to say here. More weight and more stronger it is becoming as compared to lower ratings. With the change in pressure rating class, flange dimensions vary, and hence the flanges of one pressure class may not fit with the higher or lower class. Okay, if you see, all these dimensions will change with the increase in rating. If you see, we cannot bolt 1500 pound flange with the 150 pound flange. Why? Because there will be more number of bolts. Okay, the size will be different for both the cases, so bolt dia we cannot match for different rating of flanges. With the increase in pressure rating, the number of bolts increases with the increase in bolt area. Now this is very interesting fact. As the size and rating is increasing, number of bolts will also increase. Okay, as the number of bolts are increasing, bolt area will also increase. Okay, the increase in bolt area reduces flange leakage tendency by increasing force and moment carrying capability. So it is also adding to the strength of the flange. Okay, more number of bolts, more bolt area, more tightening, lesser leakage chances. Okay, so this is all about flanges. I mean, we have tried to just understand how flange ratings are involved, how it is improving with increase in size and with increase in pressure class. So these three topics we have covered in this video. Some definitions, then we have taken an example of a material, then we have tried to relate it with flange ratings. So as you know, we have covered all these videos in different sections. You can subscribe to Oil and Gas Funda's channel. Okay, if you see, we have mentioned all the Facebook pages. We have created one Facebook page, that is you can search at the rate of oil and gas funders on your Facebook account, and you can subscribe to that page, and you can join Facebook group where we can discuss so many things related to each and every video, and you can just look into other people discussion also. So let us subscribe to this channel, like, share, to spread the knowledge. So more people will be involved, more discussions will be there. So all and further detailing we can do for each and every topic. So I hope you enjoyed this video. See you in the next part. Thank you very much for watching this.